Water quality is one of the most important responsibilities of a water utility. There are numerous state and federal regulations that focus on making sure the water delivered to customers meets specific standards and is safe to drink. In addition to treatment and disinfection processes, water utilities must perform system maintenance in order to ensure that water meets both health and aesthetic quality standards. One of the more common maintenance activities utility workers perform is flushing. Pipes underground carrying our drinking water can sit unused for periods of time and become stagnant. In order to move this stagnant water, utility workers flush water from a fire hydrant or a blow-off device. A blow-off is a pipe connection at the end of a cul-de-sac or dead end, allowing water to be flushed through it. Flushing programs vary from agency to agency. Some have routine flushing programs where specific hydrants and blow-offs are flushed on a specific frequency, while others might be more reactionary based on specific customer complaints. However, in times of drought, all flushing programs might be suspended except for extreme problems. Flushing programs are designed to move water through a specific pipe to improve the aesthetic properties of the water and prevent further stagnation of the water to the point where the disinfectant residual is completely gone. There are several steps to a flushing program. First, the utility workers must identify the area or areas that need to be flushed. This can be done based on a routine frequency or from a specific customer complaint. Once the area has been identified, maps are used to assist the workers with information about the distribution system and the component to be flushed. These maps have pipeline sizes and lengths, fire hydrant or blow-off sizes, and may contain information about the number of customers within the specific area to be flushed. Crews will dispatch to the area to set up traffic control if necessary and the required best management practices to prevent sediment and debris from getting into storm drains. A diffuser is attached to the hydrant or blow-off. A diffuser allows large volumes of water to be flushed and controls the flow to a specific area. If a diffuser is not used, flows can travel many feet at high velocities, damaging property. Once the diffuser has been attached, and prior to flushing, the water needs to be dechlorinated. Chlorine is used by water agencies to disinfect the water supply, protecting public health from harmful microorganisms. However, if chlorine is left in the water supply when it is flushed, it can be harmful to aquatic and plant life in the water body where the discharges travel. The most common types of dechlorinating agents are sodium thiosulfate and ascorbic acid. These are commonly sold in the form of a tablet and can be installed directly inside diffusers. Chlorine levels in the form of a residual are measured before contact with the dechlorinating agent and after to ensure that the chlorine is being reduced to less than 0.2 milligrams per liter. The chlorine residual before contact with the dechlorinating agent can also be used to determine if the chlorine residual within the pipeline is at an acceptable level. Acceptable residual levels within a distribution system can vary, but are usually in the range of 0.5 to 2.0 milligrams per liter. Many times, meters are used to measure the volume of water being flushed. This can help in determining how long an area needs to be flushed, and can also be used in calculating water loss volumes for the utility. Flushing can now commence. The amount of time each area is flushed is dependent on several factors. It is common practice for each pipeline leading to the hydrant or blow-off to be flushed 2 times the volume in the pipe. Utility operators calculate how much water is in the pipeline leading to the hydrant or blow-off and can use this calculation to determine how long they should flush. Here is an example of this type of calculation. Let's say that a water main in a cul-de-sac is 8 inches in diameter and 100 feet long. The volume formula for this cylinder would be used. First, the diameter of the pipe should be converted from inches to feet. Then, multiply 35 cubic feet by 7.48 to get 264 gallons. Sometimes, chlorine residuals are used to determine how long to flush. For example, if the desired chlorine residual for the area is 1.5 milligrams per liter, the operator will monitor the residual before dechlorination and stop flushing once the target is achieved. In some areas where water is stagnant, it can have a discoloration upon flushing. Utility operators might use this as a guide and stop flushing once the appearance of the water becomes clear. Once flushing is complete, the utility operator logs information in the flushing data log sheet. Some utilities use mobile computing devices to log the information. Typically, the following information is recorded: flushing location, date and times the area is flushed, chlorine residuals before flushing, after dechlorination, and after flushing, length of time flushing, volume of water flushed, any notes about the appearance and quality of the water. The utility operators will then disconnect all the equipment and proceed to the next location. Flushing is a routine task that all utilities should perform to ensure safe quality water is being served to their customers and to properly maintain their facilities.